My name is Jonathan Martinovic, and this is my final project, the dreaded recycler robot named Leroy. The main design was based off an old World War II tank design known as the BT-7. The chassis was a simple set of plates and metal stringers. I used mostly nylon lock nuts at this point, so it wouldn't shake itself loose somewhere I couldn't get to with tools. All the major components were built in modules, like the front sensor module here using ultrasonic eyes and the 3 line trackers for guidance. This gave me the ability to build in sections rather than maneuver the robot as a whole while building it up. Here is the installation of the main motor drives and tracks along with the guiding wheels for it. I went with the track method because it had 0 turning radius, and so I would have as few rotating wheels as possible. It took a lot of setup with the nylon lock nuts, and the tracks had some slack I could never get out of them. The tank treads also meant I didn't have any wobble problems I had with the standard wheels. Next, I set up the Arduino module at the front. I did this out of the need to create space for the battery, the turret, and the bins. I put the installation of the sensor module right below it so I could easily wire it up to the Arduino module itself. The potentiometer was set as a turret positioning sensor, along with all the standoffs used to hold up the turret and the bins off the chassis. Getting the wiring correct took a few tries, with the majority of the wires going along this conduit and going underneath the turret through the standoffs. The arm motor was built into the turret box with a push button installed on top. I first thought to use this as a start-stop button, however it became much more useful for running through troubleshooting functions. The arms use a high torque gearing so it can grab and lift the cans without straining the motor. Another potentiometer here is used to sense the position of the arms, similar to the potentiometer that is installed on the turret. Here's the basic claw set. I have an L-shaped claw on one side and the other with a color sensor to differentiate the can colors. The servo motor is geared with a 1-to-1 ratio for both claws and using an idler so they both turn the same way. The final part was the bins, which, after trying to attach them for about an hour, I decided it would be easier to build my own. I used a few metal stringers to create the frame and then wound string to form a netting for the floor. I used standoffs to create a fence for both bins, and in the end this was much easier attached to the robot chassis than the normal blue bins. Here I added some slope netting to try to get the can to roll away from the drop point. It didn't work, but since it didn't hurt anything either, I left it in place. Programming was created in functions, with the main function being a simple set of decisions with a set of functions controlling actual movement. Here I created a sensor calibration function, which gave me a quick way to troubleshoot if a wire had come loose or if I could tighten up the line tracking a little bit better. Where to set the values of the potentiometers for each can scanned, or how close the can should be before grabbing it. I did the same thing with the motors as well. Each motor command could tell where to set the arm or turret. Using this, I could tweak the speeds and positions of each motor and component. The coding and setup of the 2 calibration functions took about an hour. It probably saved me multiples of that time in testing. Now here's my final working test. My biggest issue was the fine control needed to use the arm properly. The constant tweaking of the robot's claw, motor speeds, and finding the exact value for the ultrasonic sensor meant by the time I made this video, it almost always picked up all the cans without trouble. I will admit, it took me just about as long to get the values right and test it as it did to build the robot in the first place. So in conclusion, this final robot seemed insurmountable at the beginning of the build. By the end though, the final test turned into a simple set of tweaks using some clear, concise code work. I enjoyed the build work and learned how to clean up messy code into something that could be modified without much worry about its effects on other parts of the program itself. Thanks for watching.